Okay, so for this problem, we're asked to find the domain of each of these functions that are created by combining the function f of x, which is 1 over the square root of x, and g of x, which is equal to x squared minus 4. So the first function that we need to find the domain for is f of x over g of x, or f of x divided by g of x. Then we're asked to find the domain of f of g of x, so composing g inside of f, and then the other way around, find the domain of g of f of x. So for each one of these, we're going to first find the function and then look at it to see which x values we cannot include in the domain. So to find f of x divided by g of x, we could take f of x divided by g of x, literally. So the f of x function is 1 over the square root of x, and the g of x function is x squared minus 4. Now, we are going to simplify this a little bit more since we actually can see this as a fraction divided by a fraction. If you put x squared minus 4 over 1, you can see this as a fraction divided by a fraction. And the way to divide fractions is the keep, change, flip method you may have heard of. Keep the first fraction the same, change from division to multiplication, and then flip the second fraction. Now, when we multiply straight across, we have 1 over the square root of x times x squared minus 4 as a quantity. And when I have it like this, it's a little easier for me to see what I need to restrict for x. First of all, we know we can't have any zeros ever in the denominator, or rather we can't have a factor of 0 or just a total product of 0 in a denominator. You can't have 0 in a denominator, so this part right here, the square root of x, that shall never be allowed to be equal to 0. And the x squared minus 4 portion can never be allowed to be 0 either. So I'm going to write that over here. So we have two restrictions, and we're going to solve for x in each one of those. But the one on the left, we have to go a step further because we know with an even root, we can't have a negative under there. So not only can the square root of x not be 0, but the x part has to be greater than or equal to 0. Now, because we said we don't want 0, we're going to get rid of the equal to 0, because normally you can do the square root of 0, but that would make, since the square root of 0 is 0, that would be a problem. So we're going to say that x has to be strictly greater than 0. For the blue part, we're going to solve for x. We're going to say, adding 4 to both sides, we have x squared cannot be equal to positive 4. Then, if we take the square root of both sides and make sure to put a plus minus on the side opposite the variable, the square root of 4 is 2. So we have x cannot be equal to plus or minus 2. Okay, so now that we have those restrictions mapped out a little bit, or at least written out, we can put them on a number line and determine where there's overlap. Because whatever we choose for the interval of x for the domain, it has to work for both of those pieces. In other words, it has to not make either one of those pieces problematic. So we're going to make the number line, and for the red part, we said that x cannot be equal to 0, but it can be greater than 0. Okay, so we have that. Then for the blue part, we said that x cannot be equal to negative 2. Well, negative 2 is already outside the red part, so we can't use that anyways. And then the positive 2 is actually within the red region, so we're going to have to make a break in the interval there. So in interval notation, that would be starting from 0 but not including it, all the way up to 2, then break and start on the other side of 2 and go towards infinity. So we have a union for our first answer. So that is the domain of f of x over g of x. All right, now we'll go on to the next part. Now we're going to do f of g of x. So f of g of x is where your g of x function gets inserted where the x normally is in the f function. So we can start by writing out the function f of x, and instead of putting an x under the square root, we're going to put all of the expression to the right of g of x squared minus 4. Okay, so what we're going to do is take the radicand x squared minus 4 and say that it must always be greater than 0. Adding 4 to both sides, we can say that x squared must always be greater than positive 4. Now we have to be careful, because if we just take the square root of both sides, we're going to get something that's actually not correct. If you take the square root of both sides, then you might end up with x is greater than plus or minus 2, right? Because if you take the square root of x squared, it becomes x. If you take the square root of 4, that becomes 2. But we have to remember that with squares, if you are taking the square root of both sides to put a plus minus on the side opposite the variable, all that's correct and works well if it's just a regular equal sign. But since it's saying that x squared has to be greater than 4, when we get x squared is greater than plus or minus 2, that's not correct, and you can see why when you put it on a number line and think about the values that are in each region. So if I go from x equals, or x is greater than positive 2 to the right, all the numbers in this region would work, because when squared, they would give us something greater than 4. For example, if we used positive 3, 3 squared is 9, and 9 is greater than 4. So that works. But saying that x must be greater than negative 2 is incorrect, because then you're including all these values, and you can see that if you were to put in, say, 0, well, 0 squared is not greater than 4. 0 squared would give you 0. So something's wrong with that second part of it. So it is correct to say that x is greater than positive 2. So that is part of it, part of our domain. So 2 to infinity, that's going to be part of it. But we're going to have a break, because we can't include values between negative 2 and positive 2. What it actually should be is going the other way, greater, or I meant to say less than negative 2. So values down this way to the left of negative 2, such as, say, negative 3 as an example. Well, negative 3 squared will give you positive 9, and positive 9 is greater than 4. So that's what we want on the other side, from negative 2 down to negative infinity. Okay, now we're going to do g of f of x. So that means that f of x is going to be inserted inside of the g function. So we can start by writing out the g function, but leaving space where the x is, because now we're going to put the f of x function right in there instead of the x. Okay, so from here we can see that the square root of x, which is in the denominator of a fraction, has to not be 0. And furthermore, the x underneath the square root cannot be negative, right? So when you combine those two together, you get that x has to be greater than 0. And that is how we're going to make our interval. So from 0 towards positive infinity. And I just want to show you something that happens sometimes with a problem like this, is you might try to simplify first. If you were to simplify the 1 over square root x quantity squared minus 4, and simplify that to 1 over x, since when you square 1 over square root of x, it becomes 1 over x, then you might end up with just saying that x is not equal to 0, and that would have not been correct. So just be careful to consider what the original function was like, because we have that square root there in the original f of x function. We had to make sure that it was not only not going to allow x to be 0, but also that x would be only positive numbers.